Hello everyone, and welcome back to another Tesma's Craft tutorial. This is an intermediate tutorial between yesterday's tutorial and what's going to be part 3 in next week. So we're going to do a few things. So first, it just caught my eye when I opened this graph, which is we use an absolute value function for this line because this line right here, this half of the line is basically the opposite of what this line is right here. And the same thing can be said about, no, we only use one absolute value equation, but we can use the same idea for this one. So this line is just a mirror image of the other line right here. So we can make one of these an absolute value function. So I want to try out some stuff. Okay, so it's not what I thought it was going to be, but we can still find an equation of a line that passes through these 2 points and then find an equation of those lines. So what we're going to do in this tutorial is just find equations of lines through 2 points. So first one, as I promised you from yesterday, well, I didn't promise you, but what I was planning to do is find an equation of the line that goes through points negative 0.25 and so I want to write down these 2 points on the side. So negative 0.25, then we have, wait, we can actually calculate what this point is. Okay, I'm going to open up a Google Doc and then I'll calculate the equations of these lines with you. All right, so I have the Google Doc open. I'm just gonna bring up points over. So points that we have. So we have one set of points, negative 0.25, and here's 0.25 0, and then we also have. Let's find out what that point is because the equation of the line that we have down. The equation of the line that we have, x squared plus y squared is equal to 4. And we know that the y value has to be equal to, the y value is 4, not 2. Let me check that. Yeah, it is 2. Or negative 2, but it's going to turn out to be the same. So we can say x squared plus 2 squared equals 4. That is interesting. Well, it's 4 squared. Okay. We're going to fix that. Okay, so in that case, we have x squared plus 2 squared is equal to 16. Which means that x has to be equal to the square root of 16 minus 4, which is the square root of 12. It's plus or minus because we want all values of x, and we're obviously interested in the negative value. So I'm going to write that down, plus or minus square root of 12. This thing can recognize it. And it did. Okay, so the one that we were interested in is x equals the negative 12. So we have negative 0.25 comma 0, which is just negative 1/4. And then we also have I put the 2 points down here. Negative 1/4 comma 0. And we have okay, so through 2 points there's exactly one line. And so we need to do a few things. So first we need to find out what the slope of this line is. So we're gonna do find slope. That's going to be negative 2 minus 0, or just negative 2. And then we have negative square root of 2 minus negative of a half. So that is going to be just negative square root 12 plus 1/4. Wait, now it shouldn't mess with. Okay, yep, it didn't mess with it. So this is slope of the line, and the calculation is going to get really messy, which is why I made a separate episode, because those who are not interested in doing some back work, they can just simply skip this tutorial and just do the one on Saturday. Okay, and then we're going to use this general equation, y equals mx plus b. And all we need to do is choose one point. And which one's the easiest? We can put it 0. Well, there's 0 for y, but that's okay. Still makes our calculation easier. Okay, so we're going to have 0 is equal to. It's going to cancel out, that's annoying. Plus, slope is negative 2 negative square root 12 plus 4. That times x, oh my, mx plus b So b is just going to be the opposite of what this is. Okay, I actually see what b is. It's not as bad as I thought, because negative 2 times 1 is negative 2, and when we multiply 4 across, we get 4. We get negative 4 times the square root of 12 plus 1, because 4 times 1/4 gives you 1. So we have negative 2 and 4 square root 12 plus 1. Okay. Yeah, and it makes sense for b to be negative because it's negative and negative makes a positive. And when we subtract it over, it becomes negative again. Okay, which means the equation of this line is y equals I don't really feel like writing this down anymore since it takes extra writing to make this look the way it should look. This is mx plus it was right minus 2 okay, alright, so let's find the equation of the other line. Alright, so this is the equation of one line. We'll find out if it works. So that's for the other point. The other line, we know 2 points still. One of them is at the origin, and the other one intersects at the exact same point, and that point is negative square root of 12. And negative 2. Okay, we have a few saving graces here. So since 0, 0 is one of our points, the slope of this line is just this negative 2, because negative 2 minus 0 is negative 2, divided by the negative square root of 12, because this number, for the same reason, subtracted by 0, you still get the same thing. So which means it's just 2 over 12, because it's 2 over 12 because the negative divided by negative, you'll get a positive. Okay, and then we're gonna simply use y was mx plus b to find the equation of a line. And since we have zeros here, 0 will have 0 is equal to 0 times 0 times x, 0 times m, or m times 0, which is just 0. So we're just left with 0 plus b, which is b. Because b is a 0, and therefore y is just equal to is distributed to this equation. My mistake. Okay, and for those who want this rationalized, is square root of 12 over 6 times x. All right, so first let's actually try out these two equations. All right, so I put the equations into the equations line right here. So this is the big long one that we found at first. So put it on, and it matches this line perfectly. And we try the other line, which is the easier equation that we found. It matches this line perfectly. If you're wondering, 2 over the square root of x, 2x gives the same equation. Just one of them follows the grammar rule. The other one doesn't. That's what happens when you write in LaTeX for too much. Okay. All right. So now we want to find what is this other line right here. Okay. So with this first one, we're going to use the absolute value of it. I'm just going to flip it upside down. And we just change the y boundaries to go from -2 way up to 0. This allows us to take out these two equations right here. And now we replace them with this better equation that we have. So we shrunk two trig equations, well, equations with trigonometric functions, which evaluate two constants into a single line that describes them both at the same time. And as for this one, let's try a few things. Okay, even I'm not too sure what the equations are going to be. So I'm going to mess with a few operators. Interesting enough, this actually worked out. Okay then. All right. As for what that's going to be, okay. In that case, we found intersection points. Okay, so I don't want to use decimals. So for that reason only, we use longer bounds. So right. Okay, I forgot what this point is. We found it, I believe. Let me look that up. It's negative square root of 12. Well, that's true, though. We could have used y boundaries, why not did I not think of that? Yes, because I would have ended at where these 2 points met, which we didn't need to. Okay, so with this equation, we can just take out change the visibility. So we can find out where just these 2 tables that we made. Because yesterday I wanted to just finish quickly and didn't want to waste your time finding the equation for those who didn't want to. Alright, so we shrunk this down to 6 equations. 1, 2. I don't know what this is doing here. This shouldn't be here. So I have 1, 2, 3, 4, 5. Pretty good for something that looks relatively complicated. Right, so this tutorial went longer than I wanted to be because of all the calculations that we had to go through, but that's okay. It was worth it. Only shrunk this down from a pretty big page of equations to just 5 equations. All right, so thanks for sticking around, and I will see you on Saturday.